Hello. In this hands-on video, I'll implement encapsulation and validation in DrawingApp 1.3, as explained in the introduction video. Let's continue where we left off in DrawingApp 1.2, and to summarize the problem in that version, well, we can pass invalid data to a rectangle object. So specifications for X and Y were between 0 and 1000, and the specifications for height and width were between 10 and 500. But here I deliberately assign values that do not correspond to any of those specifications. And when we print out the object, so when I run the code, well, as expected, we passed those values, so we see them in the printout, but the application should not accept those values. And the area or perimeter, we have negative values. That cannot be accepted. How am I going to solve this? By, first of all, encapsulate my data and then perform validation. Now, before anything, I'll create the necessary packages for version 3, encapsulation and validation. Add to the lib package, right-click, new package, DM03 encapsulation validation, and do the same for the app package DM03. I copy the rectangle class of the previous version to the new version, copy paste, and I do the same for the drawing app. Copy, Ctrl C, and paste, Ctrl V, drawing app. And then I make sure that the drawing app is using the rectangle of the new package, demo03. Rectangle. I'm going to simplify the drawing app first of all. So delete codes and rename rect2 to rect1. So right click, refactor, rename rect1. Run again to see whether everything's okay. The output seems a bit strange. I have much more output than I'm expecting because I'm only printing 2 lines. What is the problem? Well, whenever you press the green arrow here, he's going to execute the last executed app, which is the drawing app of version 2. If you want to change this one here, well, the easiest thing to do is click one of the green triangles of the app you want to launch. Run. And now I have the output as expected. As expected, but it's not what I want. These values may not be accepted. So let's perform encapsulation and validation. And I'm going to demonstrate first of all with the height property, as explained in the introduction video. The core problem is that I can assign any value to height. Well, the first step is to block this direct access. How can we do this? By changing the access modifier to private. Already IntelliJ displays one related problem, and the problem is in the app. A compiler error is generated. What does it say? Height has private access in the rectangle class, which is correct. Okay, but now I can't change the value anymore. How do we solve this? By adding a public method, public void set, and then the name of the property, set height. It accepts one parameter, a height, which will be passed by the client. And what is it going to do? This dot height is height. And that's all. Back to the app. I put this one in comments and I replace it by rect1.setHeight. And because it's public, I have access to the set. And I want to pass minus 100 because that's what I'm testing against. I don't want the rectangle class to accept this value. Let's see what happens. Run. And actually, as expected, the value is still minus 100. It makes sense that the value of minus 100 is still displayed, because the only thing it does is copy the value we received from the client and assign it to the property. Why should there be another value? the runtime doesn't know what our specifications are, we have to tell him. How do I tell him? Well, by implementing the validation as follows. I have to test the value of the parameter height. So if height is greater or equal to 10 and height is less or equal to 500, then we accept the value. Else we don't accept the value. And what we have to do here will actually depend on the user specifications as well. What does the user want us to do? Probably be notified. And the way we do this, well, so far to notify, the only thing I can do is print information to the console. We saw in the earlier video that printing to the console was a bad practice from a library class point of view, and that we replaced it by the method returning a string. But now the purpose of the set method, the setter, is that it doesn't return anything. So we don't want to change the return type of the method. So the only way we can notify the client for now is printing information to the screen. I'm going to paste some text here. So rectangle, the name of the class, invalid height, %d, %b, %d. Well, so first of all, I'm going to pass the value of the height that I receive from the client. Then I want to print out between braces what the minimum and maximum values are. So they are 10 and 500. Run the code. And this time we see the error message occurring, because what we try to do is assign a value of -100 to the height. But he's not going to accept it. We arrive in the else part of the statement and we print out the message rectangle invalid height -100 is the value that we received, and then the minimum and maximum values that are allowed. After which I print out the rectangle and we see that the height is 0, so we didn't change anything. Now I just want to focus your attention here on the fact that this is the bad practice. So we notify the clients. So we use print for now. But remember, this is bad practice. I'm going to paste some text. Bad practice printing to the console in a library class. How can we notify the client? Replaced by exception handling. See later. And with the see later, I mean, well, I still have to create those modules at the time of this video. So hopefully I'll be able to create modules that explain the correct approach. That for the setter. What if the client wants to just access a property, read out a property, as in the following scenario. Int height is rect1 dot height. Well, it can't do that because the height property is private. How do we provide access? Well, by adding another public method whose sole purpose is just to return the value of the height property. Public int get height. No parameters, and it's just returning the height property. Now here we refer to the instance data member of the object. So whether I put this dot height or just height, it comes down to the same thing. I'm going to keep this dot height for now. Okay, let's test that in the client. So rect.height is not possible. Copy paste so we can see where we came from and replace it by get height. And then to print it out, height is %d. Note that this is the height, the local variable here. Okay, let's run the code. And we see that the height is indeed 0. Okay, so I have tested for now. When I pass an invalid value that doesn't fall between the minimum and maximum, the value is not accepted and the property doesn't change. Let's test it with a value that does fall between those limits. So what if I pass just a positive value, 100? This should be accepted. So run the code. And the height is indeed 100. So whenever I pass a value that doesn't fall between the minimum and maximum, of 10 and 500, then the value is not accepted and we get the printout, the bad practice for now, but I'm just going to keep on doing this for now. So to resume, what have we done? We have encapsulated the data by, first of all, step 1, setting the instance member variable to private. So any other class, in this case our DrawingApp, does not have access to that property. How do we provide access? By providing a pair of public methods, get and set methods. The sole purpose of the get method is just to return the value of the property. The sole purpose of the setter is to accept the provided parameter if the test succeeds. Otherwise, we notify the client. And so, we may picture this private variable as being protected or encapsulated by this pair of public get and set methods. Encapsulation. Good. Now I'm going to refactor a little bit because I don't like the use of constants here. 10, 500, 10, 500. I have repetition. What if the value changes? What if it has to be 20? I have to change it here. I have to change it here, etc. So how can we solve this duplicate code? By introducing constants. Just some final. Min height is 10. And max height is 500. So replace this here, the 10 by min heights and the 500 by max heights. I'm refactoring the code. And so clearly, if the specification changes from 10 to 20, I just have to change it in one spot. Let's test it. So run the code. I'm passing a height of 100, and that seems to work. Let's pass another value, but after the first printout here. So I'm going to perform 2 printouts in a row, but I'm going to change the value to 501. Run the code, and so that value should not be accepted, and the height should remain 100. And indeed, so this is the first printout. This one. Then I'm trying to set the height to 501 and I get this error message. 501. Then the value is not changed. We are just being notified. And at the second printout, we indeed see that the height hasn't changed. And the height is still 100. That for encapsulation and validation. For the height property, now I still need to do that for the remaining properties of x, y, height and width. Now before anything, I'm going to create a new comment block, because the get and height, they are not instance member variables, but they are getters and setters. Okay. So I'm going to do exactly the same, perform encapsulation validation for the remaining properties x, y, and width. But I'm going to pause the recording and see you after the implementation. So I'm back. I've encapsulated the remaining properties, so x, y, and width. So now all the properties are set to private, and for each property did I provide getters and setters. So I have a get x returning the value of just x. Then for the setter, I have performed my validation, so I provide a few constants. Min x0, max x 1000. I check against those values, else I print out invalid x. Similar for the y. So I have a get y and I have a set y. The height is what we've seen before. And then for the width, I have something similar. Return width and set width with validation. So same values as with the heights, 10 and 500. I have an additional method, set position, which allows the client to specify an x and y value immediately. And here it's important to call the setter here and not have the same implementation as the setter, and make sure that the validation is implemented at only one position in the code, in the setter. and the same for set y. And then the remaining methods, we've seen that in the previous video with the toString, get area, get perimeter. Let's test the encapsulation in the app. So I've commented out the previous code because it doesn't compile because of the private access modifier. The client has to go via the setters. Let's do it set x and pass the same invalid values, -10 for x, 2000 for y, -100 for height, and 5 for width. I'm going to print it out and then just ask for the heights. So run the code. What do we get as output? Set x, invalid x -10, it has to be between 0 and 1000. Set y, invalid y 2000, between 0 and 1000. The height we've seen before, and for the width, invalid width must be between 10 and 500. So that seems to work. Let's pass in some correct values now. So 10, 20, 100, and 200. Run. And now we have no error messages anymore. With all valid properties, we see the height 100. One last thing, what about the area and perimeter? Run the code. And we have an area of 20,000 and a perimeter of 600. That is much better. This for encapsulation and validation. Now, time to look at a problem that we have in the current implementation, 1.3. Let me add this little comment section. And what I want to do is create a second instance of rectangle. So copy some code. So right click, refactor, rename to rect2. And pass in some other values, 30, 40, 300, and 400. Run the code. And that all seems to be fine. Okay, but now let's compare the instantiation and setting the initial values of rect2 to the code we have for rect1. So we create an instance and then we set the properties. Just going to remove these 4 lines for a sec. So if we compare this code, we need 1, 2, 3, 4, 5 lines in order to create an instance and setting initial values. Here as well, 1, 2, 3, 4, 5 lines just to create an instance and setting initial values. Wouldn't it be handy if we could replace the 5 lines just by 1 line? That's the first problem. The second problem is that, well, whenever I create an instance, and suppose I don't set the initial values to some specific value different from the default values, well, let's run the code and look at the last line. We see that the object is actually in an invalid state. Height and width cannot be 0. That's why we performed encapsulation and validation in the first place, in order to be able to pass correct values to the properties so as to set the object in a correct state and not in an invalid state. This is invalid state. X and Y may be 0, but not height and width. That is the second problem we currently have. How to solve this? By using constructors. And that is for the next version. Thank you for watching this video, and if you liked it, thank you for pressing the like button or subscribing to my channel. Thank you. Bye.